Hey students, this is lesson 511. As you can see in this lesson, we are going to learn how to use a distributive property to expand expressions and write in factored form. And we're going to learn how to simplify expressions using the distributive property and by combining like terms. So the first thing I want to do is just kind of review what the distributive property is. And I'll put that right here. Distributive property. And you should take notes here. It looks like this when it's written symbolically. And what the distributive property is to get rid of the parentheses. So this is called factored form. And to put it in expanded form, we're going to multiply A times B and also multiply A times C. You can also do that with, and this is called expanded form. You can also do that with subtraction. Equals A times B minus A times C. And just to show you how that works, let's say I want to do 4 times quantity 3 plus 2. Now, of course, I could just add 3 plus 2 first, which is 5, and multiply by 4. But I could also do 4 times 3, which is 12, and 4 times 2, which is 8, and add them that way, and get 20 also. And some of you are thinking maybe that's not the most useful way for handling these, but in a lot of cases when we're dealing with problem solving, writing expression and equations, it's very helpful to know that. All right, so I'm going to do an example here of where you would use the distributive property. Go to page 4. And right here it says use the distributive property to rewrite each expression, then draw a rectangular diagram that shows why they're equivalent. So we're going to use these rectangular drawings. But remember what I said, when you're using the distributive property, you multiply the number right here times that number, and that's B times B, which is B to the second. And then you also multiply this number by that number, which is B times 4, and I'm going to write it this way, 4B. So B times B and 4 times B. Now, just to show you how that works using a rectangular diagram, I'm going to let this dimension be B units long. So that's the number outside the parentheses right there. And then this dimension is going to be a little longer. It's 4 more than B. So from here to here would be B, and then this is 4 more. And I'm just making that 4 up, but some number 4. Now, our expression represents the area. If I look at what is the whole area of this entire figure, like this, I need to multiply length times width. Length, my width is B, and my length is 4 more than B. So that's B plus 4. And that's this dimension. That's this top dimension here. There's B, and then plus 4 more right there. And I can also write it as 2 separate rectangles. I'm going to finish drawing this out. So if I just look at this black rectangle that I just highlighted, remember that this width here is B, and then this distance from there to there is 4. So the area of that rectangle there is 4B. And this is actually a square, and the dimensions are B by B. So length times width, B times B is B to the second. So I can also write that as B to the second plus that part, plus this part, which is 4 times B. So you can see that this expression is one way to write it, and that's in factored form. This expression is another way to write it, and that's in expanded form. Let's go ahead and do this one using the distributive property. M times M is written as M to the second power. And then I'm going to do M times 6, but it's minus, so I'm going to put minus 6M. Okay? So I just expanded that. And again, I'm going to use a rectangular drawing to help me show that. I'm going to start with a width and a length of M here. So this is M, this is M, Now, my other dimension needs to be m minus 6, so I actually need to be 6 less than that. So I'm going to just draw a dotted line in here, like I'm cutting off part of it. And the amount I'm cutting off, maybe I'll put it underneath there, is 6 units. So remember that the distance on the top side here is actually m. Okay? So now one way I can represent this, so now what I'm going to try and find is the area of this part right here. All right? So the distance, the width again is m right here. And then this length from here to here is 6 less than m. So that's going to look like this, m length times width, m times the quantity, m minus 6. All right, and another way I can look at that is if I take the whole piece here, the whole square, that square is m by m, which is m to the second. And then I'm going to subtract away the part that I'm cutting off. So this much right in this blue part. And that part is 6 by m, or 6 times m. So I need to subtract away that to get the black part of the rectangle. All right. Let's go ahead and do a couple more examples here. Skip to page 6, and it says draw a rectangle right here, diagram that models each expression. Use your diagram to help you write the expression in a different form. Well, right now these are written in expanded form, and if I drew a rectangle to represent that, I would have a c squared, so that's c by c like that. And then I have another chunk added on that's 2 units by c units, and my c units would be right there. So this part is 2c, and this side here is c squared. Now, another way I could write that is by looking at the dimensions, the length and the width. So remember, this is c. So this distance from here, I'll do this in red, from there to there is 2 more than c. So c plus 2. And then I'm going to multiply that by my width, this distance, which is just c. So this is equal to c times the quantity c plus 2. All right? All right, let's try another one of those. This one here, we have b squared minus 3b. So again, we have a b squared. We need that as a drawing. So I'm going to put a b squared here. That looks like that. And then we're going to subtract away 3b. That would be taking away part of it that's 3 units long. I'll put that inside because I'm taking it away. I don't want you to think I'm adding that on. I'm actually taking it away from the b. And so this part right here is the 3b that I'm taking away. And the whole red rectangle is the b squared. So now we want to write that in a different way. And the way we can do it is by using the dimensions here. We could write it as the length right here, this b, and then we can multiply by this distance right here, which is 3 less than b, minus 3. All right, and this last one here, do this. We need something that's 2a units long, and I think I'll do that this way. So it's 2 of the same thing. So let's say this is a and this is a. And then my other dimension is a minus 1, so that's this way. So a would be like if this was a square right here, a by a, and then another a by a. But I need to take away 1 from that, and taking away 1 is like, so this width here, this red part, we're going to take away. And that's 1 unit wide from, remember that this whole thing down here all the way to there is a. All right, so now we want to rewrite that. And notice that I have 2 chunks in here. I have this piece and this piece that I want to find the area of. And the way I'm going to do that is I'm going to take my original 2 squares right here, And those are both a squared, so I'm going to do 2a squared. And I'm going to subtract this red. And that red is actually 1 by a. So this is 1 times a, which is a here, and then a again here. So I'm actually doing, I need to subtract a plus a, which is 2a. So that's the way you would expand that. All right, there's some examples. We'll work on these in class, and I'll talk to you about this next time we meet.